In this video, our learning target will be to simplify radicals. And before we do that, just some basic vocabulary that you should know, because I'll be referring to it throughout. When you see that symbol, you guys probably know it as a square root, and you'd be right. This is called really a radical sign. And the number that's inside, let's call it just x for right now, but whatever the number is inside of a square root, that's called the radicand. So if you ever hear me refer to radicand, either in class or in future videos, I'm talking about what's inside of the square root. And then the whole expression, okay, including the radical sign and the radicand, that's just called a radical. So this entire video is going to be focused on simplifying radicals, and ultimately it all boils down to using two special properties. So I'm going to show you these properties in two quick examples, and then I'm going to show you a bunch of examples and shortcuts on using them. So the first of the two properties is called the product property. So that looks like the following. If I have the square root of two numbers a and b, and I'm just going to mention that for this to work, both the values of a and b have to be positive. So we're always going to assume we're going to be working with like positive radicands rather than negative numbers. When they're negative, we have to do something else entirely, which will be in another section. But let's say I have two things multiplied together as a radicand. What we're allowed to do here is separate and square root each of those factors of the radicand separately. So this allows us to simplify. So for example, if I had something like the square root of 18, we can rewrite 18 as the product of 9 times 2. After all, 9 times 2 is 18. Now, since these are both separate factors, I'm allowed to separate them and take the square root of 9 multiplied by the square root of 2. Now, the square root of 9 we know is the number 3. The square root of 2 is not so friendly. That's a decimal, so that stays, and we can simplify that to 3 times the square root of 2. Another property that we're going to be using today is called the quotient property. So the quotient property works like this. If I have the square root of a quotient, let's say it's a over b, what I'm allowed to do is take the square root of the numerator a over the square root of the denominator b separately. So a nice example of this is the following. Let's say I have the square root of 2 over 25. So I have this quotient. I'm allowed to square root the numerator separately from the denominator. Now the square root of 2 is, I don't know, some decimal. It's 1.414 or something like that. And then the square root of 25, that's nice. I recognize that as being the number 5. So this is just a little sample of how we can use the quotient property. Now, we're going to get into simplifying some radicals. So here are some rules to live by. So these are rules to simplify radicals. And really, there's only two. The first of which is there should be no perfect square factors in the radicand. And the way I'm going to kind of show that to you guys is we're going to look for no repeat factors. So that's how I'm going to be applying that, and I'll show you that in an example. The other thing we're going to do is we're going to make sure that there's no radical in the denominator of a fraction. So if we take care of those two things, we'll have a simplified radical. So sounds easy, but as you'll see, some of them can be tricky, and it just takes some practice. So I'm going to go through a bunch of examples. Let's call this example 1, where we're going to just simplify. Okay, and we're gonna roll through a lot. I'm gonna kind of start off with easier ones, and they'll get progressively a tiny bit more challenging. So, the first one I'm gonna look at is, let's say I have the square root of 12. This is how I recommend you try this, and I found that most students have success doing it this way. Is you're going to take a look at your Radicand, and what you're going to do is the factor tree, which you guys probably remember. Maybe it's been a little bit, but basically you break down 12 into numbers that you know multiply to make that. So I know, for instance, 12 is the same as 4 times 3. Now 4 I can break down even further into 2 times 2. Now I can't break 2 down any further, that's prime, so I'm going to circle those, and 3 I couldn't break down, that's prime. So I'm changing 12 into the product of a 2 times a 2 times a 3. And if you double check and multiply that out, that's still 12, right? Well, the key here is I'm going to notice I have a pair of the same factors here. I have a 2 times a 2, and anytime you see repeated factors, you're allowed to remove that from the square root and put that number out in front, and then you're left with all the other factors that have not been removed. So my final answer is just 2 radical 3. Let's take a look at another example. Let's look at B. If I have the square root of 80. So what I want to do is first break that thing down, and there's a lot of ways you could potentially break that down, but to me maybe the most obvious is 8 and 10. 8 I can break down into 4 and 2, and 2 I'm stuck with. 4 is a 2 and a 2, so I have a 2 and a 2, and I'm stuck with 10 is a 2 and a 5, and I think I've ran into all my dead ends. So let's rewrite 80 as the product of 1, 2, 3, 4 2s, so I'm going to do a 2 times 2 times 2 times 2 and a 5. Okay, now what I'm looking for are pairs of factors. So I have a pair of factors here, so that's going to allow me to take out 1, 2 for them. I have another pair of factors, they're also 2s, so I'm going to bring out another 2 in front for that guy, and the only oddball that's left inside is this 5. So I'm left with the square root 5. 5 I was not able to pull out, there's only one of them. So now everything that I pulled out, though, I can multiply together. The 2 times 2 becomes a 4, and I'm left with a 5. So that's the simplified version of that problem. Now let's take a look at yet another one. Let's go to another page. Let me call this one C. Let's look at if I have 3 radical 20. So I have a number out in front that I'm multiplying the square root of 20 by. I'm going to break down 20 into 4 times 5. 5 I'm stuck with, but 4 I can break into a 2 times a 2, and I'm stuck with those. So I can rewrite this problem as a 3 square root of 2 times 2 times 5. So now here I have my pair of 2s. I can pull one out, and it's going to join the 3 out in front. So in the front I have my 3, I have my special 2 that I brought out in front, so I have 3 times 2, and I have a square root of 5 inside. I am allowed to multiply these, so I have 6 in the front and square root 5 inside. Simplified. Let's see, what else do I have? I got another one. Let's look at D. If I have a radical times another radical, what I could do is bring them all together inside of one radical. This is using that product property. And so what I can do here is kind of the same thing I did before. I can break the 6 down into a 2 times a 3, and I'm stuck with each of those, right? Can't break those down. And 21 is 3 times a 7, and I'm stuck with those. So really, I have the square root of all that all together, and notice how I do have a pair of 3's in there, right? So I can pull out a 3, and I'd be left with, if I can change my color back here, I'd be left with a 2 times a 7 inside. Now, since I can't break either of these down, I'm not going to be able to pull anything else out. I do want to then just multiply them. So my final answer would be a 3 in the front and square root 14 on the inside. Let's see. I'm going to do a couple more. I think just the more you are exposed to, the better off. So let's look at a quotient rule property. So if I have the square root of 4 over 81, if I have a square root of a fraction, I'm just going to square root the top and square root the bottom separately. And I'm keeping my fingers crossed that these are nice numbers. Now, you could break down 4 into 2 and 2, but hopefully you just know the square root of 4 is nice. It is 2, right? And the square root of 81 is also nice. That's just 9. So the answer is 2 over 9. The square roots have been taken. Let's look at another one. You might be thinking we're going all the way through the alphabet. We're actually not. Don't worry. This one I have the square root of 7 over 16. So I'm going to square root the top, and I'm going to square root the bottom separately. Now 7 is prime. I can't break that down, so I'm stuck with the square root of 7 in the top, but in the denominator the square root of 16 is 4. And this is actually a fine simplified answer. I have no perfect square factors in the top, meaning I can't break 7 down into the product of any repeating factors. And 4 is not a square root anymore. It's just plain old number 4, and that's fine. Now, what you'll notice that happens next, let's do G over here. We're going to make it a little bit more tricky. If I look at the square root of 5 over 2, it looks like the two previous examples, although here, when I square root the top and I square root the bottom separately, I'm kind of stuck, right? I can't do anything with the 5, can't pull anything out, and I can't do anything with the 2 either. I can't pull a 2 out of there. But the problem is I can't have any square roots in the denominator. I'm violating the second rule. So we have to do something that's called rationalizing the denominator. So what that means is I have to multiply both the top and the bottom by whatever I see is the radical of the denominator. So if I see a square root of 2, I have to multiply that square root of 2 to the top and the bottom. Now the reason why that makes sense, although it initially doesn't, kind of looks crazy, but this number, that fraction, has the same numerator and denominator, and if you divide those, you just get the number 1. That's important because ultimately we're multiplying our original fraction by the number 1, which does not change its overall quantity or value. It's going to change its appearance and help us simplify, which is the whole point, and we don't want to change the value. So the good news is when you multiply fractions, it's easy. You multiply top times top. So the numerator, let's just write it like this. It's the square root of 5 times the square root of 2. That's our numerator. And the bottom, I have the square root of 2 times the square root of 2. Now you might say that doesn't look very nice, but I'll show you it actually is pretty nice. In the top, what I'm allowed to do is bring these together. 5 times 2 is 10, and we can't simplify that, right? I mean, that's just going to break down to a 2 and a 5. No repeating factors there. In the bottom, the square root of 2 times the square root of 2 is actually 2, and I'll show you real quick why. That's the square root of 2 times 2, which is 4, or you can pull out the 2 in front, and nothing's left inside, meaning it's the square root of 1, which is 1, and you're left with just a plain old number 2 in the bottom. So at the end of the day, guys, we're left with 10 on the top in the square root. I really should say square root 10 over just 2, and no longer is there a radical on the bottom. It's just number 2, not the square root of 2 or anything like that. I think the moral of the story is this. If you have the square root of x times the square root of x, whatever that radicand is, given that it's positive, you're going to just get x. This is going to be kind of the basis of when we rationalize the denominator. Let's do one last example. Let's say I give you, I think this is letter H we're on. If I give you 4 over square root 8. We can't do anything about the 4, but what we could do is break down the 8 into 2 times 4, and I'm stuck with a 2, and 4 is a 2 and a 2, so at the end of the day I have a 4 on top of the square root of the product of a 2, and a 2. So what I'm doing is really simplifying this radical in the bottom first. So I'm going to pull out a 2. So if I do, I'll have 4 over 2 square root 2. Now there's a problem with this answer, and the problem is right here. I don't want any radical in the bottom. So that means I have to rationalize by multiplying both the top and the bottom by whatever that square root is, and it happens to be the square root of 2. So that means if I do that, in the top I get 4 square root 2. In the bottom I have 2, this 2, and then it's multiplied by 2 square root 2. Now this has a special product. The square root of 2 times the square root of 2 turns into plain old number 2. So that turns into 2. So let's rewrite what we have. What I have in the top is 4 square root 2. What I have in the bottom is 2 times 2, or the number 4. What I'm allowed to do here still yet, and this is what makes this kind of a cool example, the 4's literally can cancel out because I'm just dividing 4 by 4, and I get just plain old square root 2. I'm going to leave you on that note. It's a long video, but I think it helps seeing a bunch of examples. Good luck with the practice quiz. Thanks for watching.